All right, we are in chapter 2. Yeah, we are in. There it is. So let's back up just a little bit before you guys start writing stuff down here. So 2.1, good, bad, or ugly. Let's do this here. Show raise your hands. 2.1, good, or let's see how to do this here. How about a one finger? We're like, it was pretty easy. 2 is okay. 3 is pretty difficult. How about that? Let's go 1, 2, or 3. Okay. Okay, cool. Thank you. And so how we display distributions, it is this. So something about frequency. How often? 2.2 is all the other stuff we do. And so now 2.3, 2.4, 2.5. So central tendency is what is the middle? Where's the middle of things? Where's the center? That's what 2.3 is. 2.4 is something called variation. How much spread there is. Good. So 2.3 is the middle. How much spread there is. And 2.4 is what's the search position of a certain individual. That's kind of what we're in the whole. The position of a particular person. And so real quick here, if you think about grade point, right? So for West Hills College students, what is the middle of the grade point averages? Is there a difference between males and females? Is there a difference between athletes and non-athletes? Is there people in cohorts and non-cohorts? That's the question, right? That's a really like study. But here we're just looking at how do I find the middle of something? 2.4, how much variation is it? Is almost all the students or all the students between a 2.2 and a 4.0? Is that it? Or is it between a 1.7 and a 4.0? What's the spread? And then the question is, particularly for you, where are you at in this file? Are you in the upper 25%, upper quartile? Are you right in the middle of the GPAs? All right. Good. Another one, maybe like this. So it's house prices. Since I'm looking at homes, house prices is a good way to do it. What's the middle price right now for a home? What's the spread of similar homes? Anyone from this kind of bedroom and bathroom to this kind of bedroom and bathroom? That particular, what's the spread? And then the question is, that particular home, is that in the middle of it? Is that towards the top? Is that like, oh wow, we're taking a party, right? Does that make sense? Good. That's jam. So the middle, how do we find the middle of stuff? And you think that's actually an easy thing, right? Like just the darn middle. So we'll kind of see how that changes as we can see. We're going to get some formulas. So yeah, we're going to have to write down some formulas. Okay, and I should say on the offset, there are 3 ways we find the middle. Those 3 ways are a little bit separate, a little different based upon the situation. As it sometimes does not make sense just to find just to add up all the numbers and divide by how many there are. I think that's the one you guys are used to, right? It's called the mean, right? You add up all the numbers and divide by that. But that would not make sense for like shoe sizes. Like what's the middle shoe size that women wear? Would that just make sense? Like add up all the numbers, divide? No, that doesn't feel right. Okay, so let's see what comes up out of this. Okay. Useful again, it's humans thinking about how to find the middle. Come up with 3 solutions. Okay, let's jam. So first of all, define central tendency. All right, so central tendency just means the center. It's the middle, if you want to do it that way. And then the word middle is kind of bad too. Like, what do you mean by middle? And that's the other question. So instead of saying the middle of the group, we just say the central entry of the group, the typical person of the group. It makes it a little bit of a bigger definition. Okay, the one we know already. And if you want to find, if you want to write down all three of them right now, that's fine too. Let's explore each one of them here. So the most common ones are mean. That's the one we know most often. Then there's something called a median, and there's something called a mode. We're going to write them down anyways as we go through them here, but at least that gives you like a little spread there. So there's three that human beings have invented to find the middle. Switching on them. That's going to go on this side. On this side. And Giselle, she switched too. So yes, just messing with my mind. Okay. All right, mean, or sometimes called the average. That's the other way that you've seen it. This one you've done since 4th grade. So you guys know this one pretty well. So what do? We just add them all up. Add up all the data entries, and then we just divide by the number of items in the list. And we're going to go through each one of these really quick here. So not that much. I do want you guys to write down the formulas, just because the formulas we're going to use them later, and it's just a shorter way to say all that stuff. And so we have something called sigma notation. That little weird thing that looks like a weird E. That little thing means the summation of all data points called X. Sigma notation. Quite a bit in higher mathematics. It's a Greek letter. It's the capital S in Greek. That's what it is. It's a capital letter. That's in the Greek language. All right, next one. So then let's distinguish between two things here. So we're going to talk sometimes about populations. Hey, we made that in chapter 1, didn't we? The difference between populations and samples. 2 people nodding. That's great. So we're going to talk about population average or the population mean. We're going to use the Greek letter called mean. That's kind of like the lowercase m in Greek. So notice we can do this. We're going to do this a lot. We're going to do like all these formulas here. So I'm going to add up all the entries of X and divide it by capital N. And capital N is the number in the population. So we're always going to use that notation. For samples, we're going to take that X and we're going to put a bar over it. And now in mathematics, there's 3 different times we use that bar. Do you guys remember in elementary school? Remember long division, 4th grade? You know how numbers repeated themselves forever? Right? We put the little bar saying it's going to repeat forever and ever, and I'm not going to write this down because it took me forever. Okay, that's not what it means here. It's totally different meaning. So if you see an X with a bar on top of it, that means you're going to add up the sample items and divide by lowercase n, which is the number of sample items themselves. Okay, we're good. Pretty easy. You guys tell me if I'm going too fast as well. We'll write down formulas. All right, all yours. Just to try, just so we can have an example. This is adults before they started a weight loss study. So let's put in correct notation into here. Real quick here. You don't need to copy down the numbers. If you have a calculator on you, go for it. Use that calculator if you like. Oh, the calculator. That's right. Something about going to the library, getting a calculator, coming back. So now we have a moment of truth here. So how many do not have a calculator yet? Or you just don't want to tell me that you don't have one. I understand. Okay, let's do correct notation first. You guys, real quick here. Lowercase mu or a mu Greek letter or X with a bar on top. Which one? Brian says X with a bar on top. Raise your hand if you agree with Brian. Brian, you have 2 followers. How many disagree with Brian? How many don't know yet? And still trying to figure it out. Okay, good. Hey, that's cool. Okay, so think about this. Is this the population of all the adults in the known universe? Or is it just a sample? Yeah, the word study kind of gives it away. That little word study right there. Study. Or sample. Hey, you know, that's kind of weird. It actually says it right there. So go over here. Sample means, so we're going to use this notation right here. So X the bar on top is what you want to answer this question. Okay, anybody got it yet? Sorry, say a little louder. Okay, 57. And usually with pounds, you can either run it off to the regular pound or a tenth off. Just kind of do it that way. So let's go with it. Yeah, summation is add them all up. So you should have had 1810, I believe. And then divide by 7 because there's 7 entries. And 258.6. You can write 259. That's fine too. And so if you needed the top red line equation there, that's fine. If you just need to put the numbers at the bottom, that's fine too. But on these homework items, you probably want to use a calculator. Okay, this is the funny thing. You guys ready? So the average is 259, let's say, right? Is there a person in the study that weighs 259? No. That's the funny thing about averages. The average actually may not exist in your data. Ronald Reagan, the president in in the 80s, right? He had a famous line that said, the average American does not exist. Because when you do averages of things, right? It says the average American is 5'6", makes $62,000 a year, has 2.5 kids. I don't know how you have a kid, but that's kind of weird. And owns a $32,000 car, right? That was like the average American. And he was saying, like, you can't just put one thing to all the people. You can't standardize everything. And so that's kind of this thing of the average person does not exist. It's a famous quote. Okay, mean is good. We're good. Let's jam. So that's fine and dandy. For something like this, this makes sense because we're just trying to get an average. And after the weight loss study, then we're going to do another average to see if the overall group lost weight. Does that make sense? That like just intuitively makes sense to us. Okie dokie. Another one we do. What do you call the median? One thing we have to do with the median is we have to order our data from smallest to largest. And this one has a little few things to sort of think through. This is by the one that has rules with it. The mean doesn't have rules. You just add them up, divide by half. Mode does not have rules. You just take it out and you're done. The median has a little bit of rules here. So 2 different types of data. All right, put that down. Let's jam. I guess two more things to write down. So right here. So we have a little problem. If we're going to choose the exact middle, it's the value that lies right in the middle. Well, if you have odd number of entries, 7, 9, 12, 24, sorry, 23, what you're going to do in the middle is easy to find. You just look from the smallest to the largest, and you pick the one in the middle. That's cool. Even numbers is a little problem. Because with even number of entries, you're not going to get that. You're going to chop until you get to between 2 pieces. So if you have an even number of entries, what you want to do is you're just going to take this. So the median is the mean. Oh, that's cool. You know what the mean is. The mean of the two middle data points. So let's practice both of those. We'll jam. That's something. Are we good? I got a person, one name, but they have their book in front of them open as well, so that's cool too. Just because you're seeing the book and you're seeing the notes and you're kind of putting the two things together, that is super cool. Good job. That helps you do the process. That's awesome. Ultimately, you guys talk to me here. Is how many have a book already? How many don't have a book yet? Okay, cool. Again, the library still has it. You guys can get it overnight, 2 hour on reserve if you like. Essentially, in the older days, what tended to happen is you and your book was the whole form of the class, right? The teacher is supposed to sort of guide you through the textbook, but essentially, like you're trying to absorb the material from the textbook. So I encourage you guys to read it. Read the textbook, see if it makes sense to you. I think I said at least 100 pages before coming to class, at least you know. Ooh, that's right. Honesty question. Here goes. How many people scanned, at least flip through 2.3, 2.4 before coming to class that had a textbook? Oh, no. Okay. Let's see if we get like 2 people by Thursday to do that. Okay, anyways, let's go with let's do an odd one example, an even example. Let's go back to our wait lists thingamajiggies here. Talk to even or odd? Odd. Odd. Okay, that means there has to be a middle somewhere in here, right? All yours. Please order this from smallest to largest. You can do this as example 2 if you like. So if you want to write down the entries, just write down those entries from the smallest number to the largest number. Okay. All right, talk to me. Your first one is? I'm going to call it. How about that? Oh, no, just progression from the smallest to largest. 2 to 3. Okay, there's 2 of them. 235, there's 2 of them. 274, 285, 290. Perfect. Okay, that should be the order right there. There are odd entries. We good? So what's the middle? 268. 268. We're done. I love median. This is so good. The only thing is you have to arrange the. The only problem comes in. What happens if we have a sample of 3,000 people? You think you want to be arranging this data? Not by hand. Okay, Jan, let's do the other one here. What happens if I take off adult that was weight 285 pounds? He got scared. He's out of here. I'm left with now 6 entry points. No fun. Okay, real quick here. If you want to write next to it, just write 6 entry points instead of 7, or even number of entry points. So this would be example 3, if you like. All right, can you guys do this from smallest to largest? Still 2, 2, 3 is there, right? Yeah. Let's see it. Oh, they are already. Oh, that's no fun. Okay. Okay, notice that we don't have a middle, right? Because if we chop off 3 on this side, if we chop this one, this one, this one, and we chop off 3 off this one, 1, 2, 3, that's the way I usually find the middles. On the homework, if you do it like this is what I do. I cross 1 out here, I cross out 1 over here. Then I cross out another one here, I cross out another one here, and it looks like I don't have a middle. I have in between 2 middles. Talk to me, anybody brave enough? What should we do? Add 35, perfect. Add them up, divide by 2. So this is the mean now. So to get the median, we're going to do a mean here. So we're just going to figure out the middle of those guys. 235 plus 268 divided by 2 gives you 150. Hey, is that a little different than what we had for the mean? Yeah, what do we get for the mean again? 250. Oh, I should go like this. Sorry, because we took off the 185, right? We should go back over here. 268. Is that different than what we get for the mean? Yeah, we have what, 159 or something like that, right? 158.6. So these numbers are actually different from one another. You figure, like, what's the center? Well, according to the mean, the center is 159. According to the median, the center is 168. Okay? So they actually are, the numbers are different. Okay, boom, we're good. And one last one. Questions? Okay. Good. Ask the questions we needed here. This is not writing stuff down for writing down safe. All right, the mode, the easiest one. Here it is. It has to, it's the one that occurs the most. That's it. This one is the one that's probably the best example here of ordering shoe sizes for a store, right? Okay, what's the average? What's the center? What's the most frequent? Actually, what's the center shoe size sold at department stores? Well, median would not make sense. The median won't make sense. Mode would actually make sense. Okay, yeah, the average or the central center size of ladies' shoes is what? Size 9, size 8.5, somewhere in that range. All right. 6.5. Okay. Okay, I don't know ladies' shoe sizes. Okay, so one little extra thing is if no entry is repeated in the data set, this is the only time where you actually don't have a number. So if there's no repeats of any single number, every single number only occurs once, we have no mode. So on the homework, yes, so I haven't counted those, I hope. Where it says like, oh, there's no mode here. Okay, and then let's go the other way. What happens if there are 2 or 3 or 4 or 5 entries that have the exact same frequency? Then we have something called a bimodal. Yeah. Then you go to what? Trimodal. You got all those things. Usually in statistics, if anything does happen, it's usually a bimodal issue. So if 2 entries occur the same greatest frequency, it is a bimodal. Okay, let's jam. Let's go back to ours again here. Right here, there's my data for my study, my weight study. All you words. What is the mode? 235, absolutely. Is it writing it down? Go for it. See if people writing it down. This one usually students just someone don't write down. Example. So circling it, whatever you want to do, circle it and just say this is the mode. Right here. 235 occurs twice, whereas all the other only once, so that one has the highest frequency, so the mode is 235. Cool, okay. So you guys remember all the way back in 2.1, we did frequency table, right? Frequency table. Okay, let's do this. Let's go back to frequency tables. This is going to get a little heavy. I think we have enough time to do the heavy stuff here. So the 3 are there. 3 are cool. Let's jam just a little bit more complicated mathematics here. So add a political debate. So this is what example 4. If you want to write down example 4. All right, we have a sample audience members who are asked to name the political party which they belong, and the responses are shown below. So we have these are frequencies, right? Ooh, trivia question. What's the best way to represent this as a graph? There's a category, right? There's qualitative data, right? Starts with a P, ends an I. Pie chart will probably be the best way to represent it. Right? The categorical data. We'll go from there, but we're going to take a look at a little more stuff. So let's go. So first things first. The response period, the greatest frequency is Democrat, so the mode is Democrat right away. We know that. That's kind of easy to see from a frequency distribution, right? And then we go from there. So finding mode in a frequency distribution, that's what we look for the most. And if it's super, like a whole bunch, a lot, then we know most of the candidates are, Okay, so let's compare the mean median mode here. I don't need to write these down if we need to. Here, it's going to just talk about it. So we'll look here, M, M, and N. They are trying to figure out the middle of the data, right? The advantage of using the mean, it's the one that we use the most. It's the one that we can just crack the numbers, divide by how many there are. At least you get some rough idea from it. Okay? Usually done with numbers. Only problem is that sometimes we have something called outliers. Sometimes we have the guy that weighs, he wants to be part of the diet program, but he weighs 120 pounds. Or the person that weighs 320 pounds, right? He's going to be really way off of the pounds there. It's not a nice cohesive whole. So that's the only problem with So that's the only problem with the mean. It could, if you have one person that's way off the scale, that is an issue. That's the issue we're going to have to handle with it later. So the question is, how can we drop the outlier? Can we get rid of it? Do we not include it in the data? Because the data will be more reliable. Okay, what does an outlier look like? Let me jump through a little bit here. Oh, here I play this. In a graph, this is kind of what it looks like this. You know, all the data is bunched up in here, and this is an obvious outlier, right? Boom, this right here. This is a sample showing. Oh, ages of students in class. Okay, I like titles in class. Okay, cool. All right, it's the retired person that decided to take statistics again. And you got the rest of the group. So the question is, how much weight do you put? Do you think their grade point average might be a little different? Do you think their goal in taking the stats class is for a different reason? Should they be included in your transfer data? No, correct. They're not transferring. Hopefully they're not just starting their education at 65. Okay, so we get there. Sometimes we have outliers. Okay, now let's get into some heavy mathematics. You guys ready? Just a little. Some people go weighted. And I think students sometimes get mixed up on just the notation here. The notation kind of gets them confused here. So let's go through it slowly. What time break hits us? All right, and how do we calculate it? Here's your weighted mean, how we do this here. And let's talk about what that even means. And so notice on each entry, it's not just adding up the x's, it's adding up the x's with the w. And the w just means how much weight or how much points is given to a certain thing at each entry. Okay, notice that there's an x bar over here, right? So we're doing the sample weighted mean. Yes, there's a formula for a population weighted mean, and that's fine too. Yes, so we're just doing a sample here. Almost all the time we're going to do sample weighted means because that's what we're going to look at anyways. Ready? You guys ready for some heaviness here? Two problems that we're going to do. So first things first, maybe a good one would be, did you guys know this? Did you guys know that your GPA, right, is based upon points? So, and based on the units you carry. Good? So let's talk about this here. You take a chemistry class, it is worth 5 units. Is chemistry class worth 5 units, guys? Anybody took a chemistry class before? Yeah. What's the highest unit value class you guys are taking? There's a class that's 6 units. 4. 4 is the highest. Okay, that's cool. Awesome. Okay. 4 unit class. This is a 4 unit class, right? You're totally correct. Okay. So then you have anybody taking a 3 unit class? Yes. Giselle says yes. Isabel says yes. Okay. This class, the A in this class for your GPA is actually worth more than the 3 unit class that you took. So real quickly here. If you got an A in this class, but you got a B in your 3 unit class, your GPA would be higher. Okay. Then if you got a B in this class and an A in the 3 unit class. Does that make sense to you guys? So you try to get the best grade you can. It's for your GPA purposes, right? So let's actually, we'll do that afterwards. Let's do the example first, and we'll jump to it. Okay, example, here it is. Ready? Your grades from last semester are tabulated right here. That's cool. That's a lot of classes. 1, 2, 3, 4, 5, 6. You took 6 classes last semester. You guys did not know that, but you did. So here it is. Your final grades are given. Your credit hours. So it looks like you get a C in a 3 unit class. You got another C in a 4 unit class. You got a D in a 1 unit P class that you didn't care about. It's really seriously who wants to learn that. Then you got an A in a 3 unit class, then a C in a 2 unit class, and a B in a 3 unit class. Are we good? Okay. Up on top, it tells you the point system assigned. So let me put in
This would be good. Let me put in values here. So we're gonna finish off the table here. This is a problem we're gonna work with right here. So if you want to copy that down, we're gonna finish it off. So here's what I want. I want, at the end of the day, I want the GPA for this person from last semester. And this is because things are weighted over here. We're good. Certain things are certain things. Let me put some formulas up because I think it'll help with formulas. Okay, let's copy down. So you're just copying down the table, right? That's what you want to copy down, table. So based upon previous formula, I'll let you guys copy down the table. Then I need to know, I need you guys to tell me what in the world is X and what is the world is W here. And can I put columns next to it? Are we missing anything? That's kind of what we're looking for. All right, so the question is, do we have X's yet? Or do we have W's anywhere in here? What are the X's that we have? Say again? Ooh, hold on. I don't think X's are ours. I think X's are the equivalent of your grades, correct? So I think we're missing X's. I don't think we have X's down yet. Are we good? Trick question. I got Tristan. This is good. That was my job for today. So do we have W's here? Do we have the weight? How much something is worth? Yes. Okay. So real quick here, over here, you're going to put W right over here. The credit hours are the weight of each one, right? The first C has a weight of 3, right? 3 units. The second C has a weight of 4 units. So let's put in the X column over here. What would be the X column? I'm gonna just say points. Points per grade, that would be their X. And so how much is the point value for a C? 2, awesome. I go that one. Point value for a D? 1. Point value for an A? Awesome. C, you said 2, and then I got myself a 3. Cool. Okay, so I got that. Now I'm gonna do this here. I'm going to make another column, and this is gonna be my X times W column. We good? Again, very easy numbers. The homework is going to have a little bit more complicated numbers than this, but still same concept. Okay, all we go. So let me go back. Real quick here. The formula is the summation of X times W. We good? Our column that we're making is we're making the X times W column. So this is going to be multiplication. You guys talk to me, make sure I can multiply correctly. 3 times 2 is 6. That's 8. That's 1. 12, 4, and 9. Are we good? Okay, then right over here, I'm going to put this. I'm going to put sigma of XW. There it is, because then at least I know where my formulas are coming from. We're good. So now I have the average of my sample is sigma XW over summation of my W's. Ooh, awesome. Okay. Jam in. Okay, you guys talk to me. What's the number on the bottom there if you have it yet? We are adding this column up right here, all the XWs, and you needed to get that answer right there. Adding my 40, anybody else? Just double checking Brian, okay. 40 it is, okay, I got 40 here, which actually makes it, if you want to put off to the side, so the formula itself, you got a 40 there. Now, what also I need to do is all my credit hours together. Ooh, so real quick here, make another little entry right over here. Make this the summation of W right here. So how many units did you take that semester? $16 units. All right, check in Jimena. Checking Jimena here. Anybody got 16 as well? Cool, okay. Boom, and then also that 16 goes right over here for a formula, and voila, what's 40 divided by 16? What's our GPA from last semester? .5, okay, that's cool, okay, boom. So isn't this interesting? I mean, those are numbers, right? And then you think about what is honor student, right? What is when the graduation happens, right? When people have a 4.0, they're given special a lace, right? Or anybody above a 3.6, I believe, is honors. And 4.0 is high honors. Okay, guys, anybody did not get those numbers? Real good. I just want to make sure. Are we okay there? Because you're going to do a homework question just like it, so might as well practice now. Coolio. Okay, you guys talk to me. Does this kind of, sort of, a little tiny bit look like a frequency issue as well? So notice we multiplied together here, right, to get this piece right here, right? Because the number of credit hours, it's almost like it's its own little frequency of importance. Does that make sense? A 3-unit class, there's a frequency of importance of a 3-unit class, right? A 4-unit class was a frequency of importance of a 4-unit class. The 1P class of badminton that we didn't care for, not that important, right? So the frequency of importance was low. So let's do that. Let's do frequency tables from 2.1. Let's connect it together to this now, okay? Let's jam. So, oh, sorry, real quick here. Didn't want to go that way, want to go this way. All right, finally at the end here. So the toughest we're gonna get right here. And we have one more example left, but we got some. We got some formulas, guys. We got some formulas to handle here. So X bar or sample mean is so it is all the times X occur. Oh, sorry, it's the X's, and then all the times X has occurred. Very good. That's kind of what we're looking at. All right, so just like the group data, this is now weighted data. So this little frequency kind of helps us out. So instead of adding up every single time a certain data occurs, we're going to multiply the number of times it occurs. That's kind of what we want. That's kind of like the fast way of doing it here. All right, since we deal with the frequency distributions a whole bunch, right? Let me give you I'm gonna give you guys some more formulas here. Ready? So let's do this here. Frequency distribution. Now, do I want to do it now? I don't want to do it now. 1 second here. Let me do it like this. Hold on real quickly here. Let's set it up. Slides, new slide. All right. Find the mean, median, and mode. How about that right here? I'm going to give you some data. We're good? Mean, median, mode. Here we go. 172.5, 172.5, 172.5, 208.5, and I'm going to go in order here because it'll be easier to go in order. 2.5, 208.5, 244.5, 244.5, 244.5, 244.5. There's a reason why this is monotonous. Just to torture you some more. 280.5 once, 280.5 twice, 3 times, 4 times, 5 times, 6 times. Mr. Angio, you are cruel. Yes, I am. 316.5, that's once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. I want out of this class. 352.5 twice, 3 times, 4 times. Okay, because Tristan complaining, I'll only just do a little bit more. Once, twice, and 3 times. There's our data right there. I don't know, we got to count. I counted 30, but you guys check here just to make sure I got the same. Just torturing you guys, that's it. Okay, are we good? Did everybody write them down? Euphora just said, forget it. I'm done. Hold on, let me do this here. All right, class, I think it's easier to go backwards because mode is probably the easiest one to do because you just look at the, no, don't want that yet. There it is. Mode. Mode is the one that occurs most often, which is 316.5. It occurs how many times? 7 times. Okay. The median. 280.5? So the way I do the middles is I count, oh, hold on, even or odd data. There's even number of data. That means we're not gonna actually have a middle. Right, we're gonna have to get the average of the two middles, right? So the way I do that, let's see, there's 30 pieces of data. So that means the middle has to be 15, right? Because the 15 and then there's gonna be 15 afterwards. Does that make sense? So I'm gonna count off to 15. And then the next one over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, okay. So here's my 15th one. And here's my 16th one. I get the average of this. 280.5. All right. That is so cool, right? Okay, now the fun one, the mean. Real quick here, can I help you guys out a little bit? Just a little bit. Notice our numbers repeat themselves. So, hey, let's do multiplication right away. We good? How about this? Instead of adding 172.5 plus 172.5 plus 172.5, how about we just do 172.5 times 3. Then we're going to do 208.5 times 2. We good there? 1, 2, 3, 4, 244.5 times 5. 1, 2, 3, 4, 5, 6. 280.5 times 1, 2, 3, 4 times 6. 1, 2, 3, 4, 5, 6, 7. 316.5 times 7. 1, 2, 3, 4. On your calculator here, 352.5 times 5. 388.5 times 2. No, sorry, times 3. To finish it off. Hey, okay, was the multiplication a lot easier? Yes, I like the multiplication part. Since you had to deal with each of the, okay, can anybody get the middle? What is the middle? A lot of tedious work, huh? That's why statisticians, they live in their office for a while and they just sit there and sit there. All right, 287.7 is cool, is super cool. Okay, are we good there? Anybody else got a 287.7 yet? Okay, I see people just staring at the screen thinking, what in the world? So the people that are staring, talk to me here. What, I can come by help? Say again, Kimberly, what'd you say? We're just trying to get the mean. And we got an answer of 287.7. See if you get the same answer. And so I really want to get this into your head. Multiplication was easier, is that right? Just this whole concept, just multiplying, instead of writing all those 30 pieces out with torture. Okay, how about this? I'm going to go backwards now. How many have not got 287.7 yet? Come by and help a little bit here. All right, guys, real quick here. How does this look like? What does this look like in a frequency chart? It looks like this, but essentially we did the same thing. Oh, sorry, real quick here. I'm going to have you guys write down formulas real quick here first, and then we'll take a look at the frequency thing here. So midpoint formula of a frequency distribution is just X equals the lowest number plus the highest number divide by 2, right? We did that, didn't we? It was 208.5 plus another 208.5 divided by 2. That's easy enough. Okay, finding the sum of the products. So this one right here is X times F. We're going to multiply these guys together. Hey, we did that, didn't we? it was the 3 times this number and the 4 times this number, right? Here's a formula for it. It's X. F is the frequency. F is the number of times it happens. We just did that real quick here. N is the number of frequencies. You add them up. That tells you how many endpoints you have. We had 30, right? And then finally, the mean. This is what it looks like as a formula. We just did this. We just found out 287.7. Kristen, did you get 287.7 eventually? Yeah, okay. Okay. Formulas in mathematics are important. You do want to write it down. You do want to have a knowledge of it. So when I say, oh, what's the summation of F times X times F? You know what that means. So if you want to write down the formulas here, it's going to help you on the homework. If you want to, that's fine. It's useful. I think it's useful. It's formulas because sometimes, especially with formulas in mathematics, we like to talk in terms of formulas. So in the homework, you actually will see like find this, and you kind of know, you need to know what that means. Okay. Okay, are we good? B and A.
Or is it the same for 3 and 4?
3 and 4. This the difference here.
On the just the definitions of the word.
Right here. Yeah, the sum of the frequencies. Sum of the frequencies is how many times everything occurred. So it's almost like the N. It's almost like how many data points you have. So notice there's connections now. Then if you were to substitute this with N, you would actually have the summation of F. So I know it's kind of weird because you have all these different symbols that come together. Real quick, guys, can you guys write for me another way to write this? So summation of all the X times F's, which is we just did, but N, is there another formula that I could put down here? Yeah, notice the N is here, right? Notice the N is here. Those mean the same thing. So you could write it like this as well. You'll see it in other textbooks, which is like this. It's the summation of the data points times F times the data points. Okay, B&A, does that help?
Yeah.
Okay, it's the adding up of the datas with how many times it occurs, and then how many times does everything occur? Okay, class, we're good? Jamming. Okay. Tristan, you good? Class, real quick here. Let's go on. So how does this look like? Almost break time, almost break. So give me about 3 minutes here. This is the way it looks like in a real true frequency table right here. Notice it's going to be the midpoints of each class. Instead of writing all those points down like I made you do and do it the long way, normally it's written down like this. We good? A lot easier. The next column is hopefully all the numbers we had. Are these all the numbers we got? Yeah, I think so, right on the previous screen. And then it's the summation of this right here. So then at the end, all you got to do is this number divided by this number, which is what you guys did. We good? That's how it looks like on a frequency distribution. And voila, 187.7 is cool. We good? Congratulations. Give yourself a clap. All right. 4 things to look at real quick here. 2 slides or 4 slides real quick here. Have some homework questions on it. What happens when the mean and the median and the mode all line up so perfectly? What does that mean? Okay, let's talk about it here. So this one right here. Sorry, Giselle, you still writing stuff down? Tell me if you need to. You good? Okay. So real quick here. Symmetric distribution. So we got 4 of these. So this is now the interplay between mean, median, mode. What happens if this is happening here? Symmetric distribution means everything is lined up. Everything is perfect. This is when the Kyle at the district office, bless you, when he sees this, he's like, yes, this is beautiful. Because everything is in nice order. Everything is unified. So notice the mean, the median, and the mode are all equal, which is what 8 in this case. So off to the side, maybe just write down this right here. Mean equals median, which is equal to mode. That's beautiful data. No outliers here. Everything made sense. We're going to call this a normal distribution if we can get there. All right, do you have to draw it out perfectly like that? No, just kind of make it so that it kind of looks like that, right? With the middle being the biggest and then everything is centered off the side. Okay, got 1 of 4, got 3 more to go here. So that's 1 that we like to see in statistics, and which happens quite a bit. I'll show you how we get there. We do like this little fun trick to get it like that. Because we could do a lot of analyzation after that. Okay, are we good? So if you don't want to put the median mode underneath each other, just on the side, just put mean equals the middle, equals the median, equals the mode. Okay, that's 1 that occurs. Cool, good. I think I got everybody done. The other one that occurs, sometimes it's like this. It's called uniform distribution. So everything is about-ish the same. So they are all equal or approximately equal. That's just about right. So therefore you have a lot of diversity and you have an equal diversity everywhere. Okay, I'm going to write to the side here. So mean equals median. And not so much as that you have no mode, but everything is almost the same, right? You can't really tell which one's the mode. Even though like 3 might occur a little bit less than 5, but it's still almost the same. All right. Are we good there? During break, if you want me to kind of go back and forth between the two to write them down, that's fine too. Okay, and the two others. We call this a skewed left distribution. So a skewed left distribution, we call it negatively skewed, but really we're looking at the tail. Where's the tail to this guy? And so notice the tail is towards the 1, 2, 3 sort of thing. It's kind of bunched up on the right. So the tail, that's kind of funny. Kind of think that you're gonna look at the other point here. How does this look like? Mode is the highest one. So mode is bigger than the median. And the median is still bigger than the mean. We don't like to use, in mathematics, we don't like to use the less than sign to go the other way. So we write it like this normally. So median is the smallest, then goes up to the median, which then goes up to the mode. We like to write it like this. This is the, we like less than symbols if we compare stuff together. So everything is a little bit heavier towards the right side. Another math teacher used to work with here. He was into real estate a lot, and he would buy homes and flip homes and all that stuff. And this is what he would look at right here. So if you have mode, most of the homes are selling at this point, but the median is lower and the middle is lower than the mode, especially this lineup here. That means the homes are a little bit overpriced. So it's like, I'm gonna wait a little bit here. And he did pretty good. Okay, are we good there? So the tail, we always look at the tail. That's kind of how we look at it. Okay, the other way around. And last one before break, this one right here. Skewed right distribution or positively skewed. The tail of the graph elongates to the right this time. And we go the other way now. So the mode is in last place. The most frequent thing occurs lower. And the median is lower than the mean. This one, house prices. Oh, hold on, a whole bunch of homes are selling at this price. The median home is selling at this price, and the mean is in the middle. Homes are undervalued. Maybe a good time to buy, depends on the circumstances. Oh, Gene. Right there, I'm going to stop here. Let's take our 10-minute break now, even though it's kind of crazy. Take 10 minutes. We'll come back in 10 minutes and we'll have exactly half an hour to go in the class. We'll try to do as much of 2.4 as possible. All right, class, we are jamming 2.4. Measures of variation. I don't think we'll get through all this. Let's just go until it's exactly half an hour from now. So we might not finish 2.4, but let's do our best to get to as much as we can. So last time it was where the middle is. Now it is how much spread in the data is there? That's the question. And it's not so much as like with the highest minus the lowest. It is more so of all the students in the class got 85% of the test versus the average is 85. But then the highest was only a certain amount, lowest was just 10 points off. Versus we had a whole bunch of people that failed, a whole bunch of people that passed, but still the average was 85. That's the issue. Is that how do you measure variation? How much do you want to do that? Okay, simplest one is just the range itself. So let's go with the range. easiest one is the range. That's good enough. It tells you the highest entry point, what's the lowest entry point, and done. Only little issue is, since we're looking at numbers, I guess I'll have to in terms of numbers. And then it's the maximum data entry minus the minimum data entry, and done. Yeah, we'll get there. Super easy, don't even spend much time. Don't need to write this down, just gonna think with me here. So starting salaries for corporation A, thousands of dollars, here it is. Da, 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 da. Nice. Starting salary for corporation B of thousands of dollars. Da, 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 da. That's fine, we're gonna deal with this in just a little bit here. But I figure range, let's not write it down just to save time here. So here it is, order the data set, helps us to get the least and greatest, the smallest. So from this is corporation one, right? Find the range for corporation one. You guys talk to me here. Lowest or the highest is 47. Lowest is 37. Lowest 37 over here. Go right there. There's your 37. Even though 38 is over here, 37. Both times lower. So voila. The range is 10. Are we good? Or $10,000. Again, I don't need to write this down. Just gonna let's go with it. The next one we need to write down. Here's where we start. You guys ready? Is variation. Oh boy. In fact, let me do this here. Let me do it like this. Sorry. I'm thinking about it a little bit better. Let's jump to this one right here. Deviation is just how much difference there is between X and the mean. That's one piece that we're gonna look at here. Okay, so first thing we're gonna do, again, there's three of them, just like mean, median, mode, right? We're gonna work with three of them. So deviation is one thing. We're gonna use something called variance is the next one. And then standard deviation would be the next. There's three. So the first one is deviation. How much is it from the X point to the mean? That's what we're looking at. For a population set, the deviation of X is equal to X minus mu. The middle for the population. For sample is the X minus X bar. We get some definitions, then we'll go back to our little, just one big example. Lots of numbers. We're going to be adding and subtracting a whole bunch of stuff. We're good. That's what we're going to need to do. So the first thing is this the deviation. Next is something called variance. Here's variance. It's the stuff that we just did in part one. We add all those guys up, we square them, divide by n, and then we have something called, oh, there's sigma. There's a lowercase s in Greek right over here. That little loop-de-loop thing. It's called sigma. It's going to be something called square. It's the square of that. Okay, that's for variance. Sometimes question comes up, Mr. Henry, why do we square it? And simple answer is because half the stuff is less than the mean, which is negative. Okay? Half the stuff is above the mean, which is positive. So by squaring stuff, we get rid of the negative. Right? We have half of the stuff. Well, if you were to not square it, you would get 0 because you would be adding up all the negatives and positives, and then you get a 0. Okay, and then one more underneath it is the standard deviation. There it is. So notice this is the population answer. We're starting off with the population issue. Then we'll jump into the sample issue later on. Maybe not today. So if you had all the data and you know you're not missing any data whatsoever, here's what we do this. So notice the population variance. It's the exact same thing, isn't it? Same exact formula, you'll see it different ways, but really the population standard deviation is just the square root of the variance. That's it. That's what it's trying to show. Here's the formula that we use. And this one is just to say, look, it's just the square root of this guy. And so on a homework, if it says the variance for this population is 3.78, what's the standard deviation? Oh, that's easy. I'm going to take the square root of that number, and I'm done. Good. Now, I'm gonna go back a little bit to here. Go back to here. Just a little bit. Corporate A, corporate B. Remember how we looked at it earlier? This is kind of the issue here, is that both of these guys have an average of, it's the same average actually. And if you actually did the median would actually both be the same. Mode would be a little different, that's about it. But which one has a more spread, right? A lot more spread in corporate B, right? Corporate A, everybody's kind of almost the same salary scale there. So that's what we're trying to figure out. Is can we get a number to this? Can we give a number that we can think about? And that's what the standard deviation is. Okay. One problem altogether. I think I set up the problem here. Let's see. Sorry about that. Let me find it here. So let's go corporation A. Let's see. Let's do it together. I guess we could do it together. Oh, not so fun. How many? 1, 2, 3, 4, 5, 6, 7, 8, 10 entry points. This is in terms of thousands of dollars. Is that right? This is corporation A. I think it's corporation A. Yeah, let's do this. Let's do this one together. Here we go. Let's do some writing. Get ready. 10, not 30 data points for today. Just 10. So not to kill you. So if we can make a table of salaries. So salaries, I just want to make sure this is the one I'm talking about. This is the one I'm right here. We're going to go back to the data again. 41, 38, 39, 54, 45, sorry, 47, 51, 1, 2, 3, 4, 5, 6, 7, 8, 10. Is that the same one that's over here? It is, huh? Yeah, that's the same. Okay, so we can put corporation A in the column, 10 things going down. The deviation is the subtraction for the middle. So can anybody real quick here, first of all, verify the mean is 41.5? Add these guys up, divide by 10. I just want to make sure that I did it right. This is 41.5. As you write down the first column, add them up, divide by 10. Oh. Or else I got a lot of things wrong here if that is the case. Correct? Yes. Okay. Awesome. Okay. Next is you don't have to show all this stuff here if you want to, or maybe like the first two show this and the rest kind of just put it down. We're good. But we're going to try to figure out the population standard deviation of corporation A. That's our job. So usually in statistics and stuff, usually when we write this down first for maybe the first two entries. So then you know what you're doing. So then you don't have to do extra work. Then you just write down the numbers afterwards. So I gave you guys the deviation. And then what I want you to do right here, give me the x minus mu squared. All right, I want you guys to notice something real quickly here. Notice some of them are negatives and some of them are positives, right? So notice some negatives, positives. So if we were to add these up without squaring it, we would get this guy right here because the negatives would just cancel off the positives and done. But I think this was such a cool invention is the fact that, you know what, if you square this number, you get rid of the negative. I believe early on what they did is they didn't square it. They just wrote like just take the absolute value, but we find some extra data in there by squaring it. So okay, this becomes a big humongous formula here. That's why I want to make sure that we go from there. Okay, so third column, that's all we need, and then we can actually calculate everything else. So let's do that. I think we'll have enough time to finish off. Okay. If you want to, you could just put in these numbers here. This is the next column. We good for you guys? So this is deviation. If you want to write the formula, x minus mu. That's column 2. We good? Write down the first formulas so you know what the formula is about, and then just write down these numbers afterwards. Boom, 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 boom. After you've done that, next column is you take each one of these numbers and you square it. So what is negative 0.5 squared? 0.21, okay. Oh, 25, okay. Perfect, okay, there's that one. And then eventually we're gonna go over here. All right, we good, good. And then let's go with it together. If you guys want to calculate yourself, let's calculate as a class here. So I need, you guys ready for column 3? Shake your head yes if you're ready for column 3. Shake your head no. Okay, negative 3.5 squared. 12.25, okay, negative 2.5 squared. Okay, and I think the rest, no, I can't do that yet. So that's another 12.25 here, 5.5 squared. 30.25, okay, that's cool. This one is gonna be another 0.25. That's gonna be another 6.25. This would be another 0.25 and 4.5 squared. See? 20.25, perfect, thank you. And then this one's gonna be another 0.25. Okay. Then we have, see, notation. We're running out of notation. What should we call this? Okay, in statistics, we call this is capital SX. Why do we do that? I have no idea. So this one is capital SX. It's technically we call it the sum of the squares. So now we're running out of notation. Do we use sigma again? No, we just call it SS. Sum of the squares. All right, can you guys do this for me? Can you add up that last column for me, please? Oh, you still guys writing column 2? Okay, go ahead, Beth. Sorry, I'll get out of your way here. Awesome, thank you. 88.5, I guess I should check. Anybody else also got an 88.5? Just to double check. See again? 94, okay. Okay, I got 3, 88.5, 94. Oh, that's a 30. Yeah, sorry, guys, real quick here. My 30 looks like a 6. It's actually 30 right here, not 36. That's a 30. I think we're ready to plug into our formula. Let's see, our formula for variance is sigma, short sigma squared. So variance, we actually just call it variance. Even though it has a little 2 on there, we just call it variance. Variance is the summation of the x minus mu squared over how many people we have in the population. That's all. So I got myself a 88.5. That's coolio. How many people in the population? How many employees in corporate A? I got 10 for you. Perfecto. And talk to me. What is the variance? Now, since looks like, notice on our data, we go from in thousands. Our deviation is in terms of one, like a tens place. This is hundreds place. So I'm gonna go like, let's go tens place. Okay, talk to me. What do we get? Oh, you know, I can do it like this, huh? divide by 10, which is just moving the decimal point, right? So 8.85, so about 8.9 is my variance. And my, eventually we're just gonna label it SD, standard deviation. Standard deviation is what we do is we just take this guy and take the square root of it. So square root of 8.9 or 8.85, just to be a little more precise. We're going to take the square root of 88.5, which is approximately. Sorry, class, real quick. Can I change something up right here? Just you're going to put these, instead of putting an equal sign, what you're going to do is you're going to do this little wavy equal sign. And the wavy equal sign just means about, not exactly. 8.9 to the nearest tenths place is pretty good. Okay, and then another wavy sign after this one, because not exactly it. Square root of 8.85, 88.5 is 9.4. Oh, yes, sorry. Class, I don't know. Thank you so much, Brian. How about this right here? 2.98, so about 3. Let's go. It's 2.98. If I'm trying to round to the nearest this guy, I look back and it's an 8, which means I have to round up the 9 one. But if I round up the 9, it goes to 10, which goes to a 3. So approximately 3.0. So my spread is 3.0. So in terms of this problem, you guys talk to me, what is my standard deviation? What is it when in terms of dollars? What is it? $3,000. So good. Standard deviation. So SD is about $3,000. Okay, are we good? We mostly are going to use standard deviation. Then later on in the class, we'll use variance to actually get some other information from our data. Okay, you guys talk to me. Does that make sense there? So just to recap then real quick here. So we took our data. We found the median, right? Sorry, we found the mean, right? Add them up, divide by how many there are, and the mean turned out to be 41.5. We used that one each time and subtracted it from each of the terms, each of the pieces, each and every single time to get this little piece called deviation. We squared it to get rid of the negative signs. Technically, that's why we squared it. We got rid of the negative signs, we add them all up, and then we plug into this formula, which is this little piece right here, the SS, or sum of squares, divided by how originally we had it to give us variance, take that number and take the square root of that number to give us standard deviation. Ooh, we are jamming. Okay. I think what we'll do is we got 5 minutes to go. Let me give you guys the formulas for. Let me give you the formula for sample.
Wait, so I have a question before.
Yeah, sure. Go ahead.
So the salary of relevance, is that all added together? That's just the median, right?
Tell me what you're saying. Is it this right here?
The salary with relevance, yeah. That's all the median, or is that all the matter?
That's this added all up together, and then when you divide by 10, it gets you the 41.5. Okay, then let's do this here. Talk to me where the confusion is, or where did you solve your confusion? Because it could be that you solve your confusion with others. The formula is okay. Gotcha. Okay, for the columns, right? So this is X, if you want to do that X, this is X minus mu, and this is X minus mu squared. So it's always gonna be 3, then you get that bottom number. Any others, any confusion? They're like, oh, now I get it now. It's the light bulb that just turned on. That's what I'm trying to figure out. Okay, guys, this is population. Population, there it is. Let's jam to sample. Sample's a little tiny bit different, still works the same, but I figure once we get this, at least that'll be good. Let me jam to this. Which one's going to give us the best one here? Oh yeah, okay, let's do this one. Where's my mouse? Last view, show. Ah, thank you. Can't see. Boom, let's go to sample variance, sample population, sample. There it is. Let's go both these guys. First things first, notice it's not Greek letters. It's just a regular old S. That's the difference. Population, we're going to use the Greek letter S. For sample, we use the English S for that one. Okay, so Mr. G, what is the difference between population and sample? It is just we divide by n-1. That's it. So if there was 10 entries, 10 salaries, we divide by 9. That's it. But the same process still works. You're still going to do the 3 columns. You're still going to square that last column, still add it out. Just divide by 1 less. And the question comes up, Mr. Angia, why would you divide by 1 less? All right, read your mind now. Is because with samples, it's almost like we think of there's some error in the sample, right? Because we don't know all the data. So with samples, we got to give a little bit more freedom, a little bit of sample error. And so by dividing by 1 less, it gives us that extra little freedom to say, you know what, there could be actually a little bit more spread. We just may not know it. Now, do you divide by, do you subtract 1? You subtract 2, you subtract 3. Human beings decided, statisticians decided, you know, 1 seems like it's the best way to do it. So it's because of sample error, just because there's probably a little bit more error in there than we're counting. Okay, I don't think we need to do another example with samples. I think we're good like that. Because the same process still works, the same thing works. It's just you divide by 1 less. We haven't finished all 2.4 yet. We haven't done something about group data. So if you go back to the homework and you're like, oh man, there's something about this right here. So if you get to 2.4, and there's some, so standard deviation of group data, and there's a theorem that we're going to talk about on Thursday. The week goes for Thursday and 2.5. I did want to say one more thing here with the 28 seconds I have left. Standard deviation, why is it so important? Because when we look at big, huge data sets, we will stop with this thought here. What, this is so cool. Standard deviation, that little number that we got, 3 or 3,000. If you do 1 standard deviation away this way, so 1 standard deviation this way, and 1 standard deviation this way. All the time, you're going to get 34% of the data here and 34 here. So we say, look, if you're 1 standard deviation away, you've captured almost 70% of the data. It should be in that 2 step. If you go 2 standard deviations away, by then you have 95% of all the data. That's a pretty good number, right? There's a little bit of 5% error on the side. If you go 3 standard deviations away, you pretty much have all the data that you need. So we normally just say, look, if you're 3 standard deviations away, that's about as good as it gets. So that's a super duper important principle stat. If you get this understanding this, the fact that 1 standard deviation away, so what was it? 41,000 and a half, is that right?
was the mean, is that right? So if we go 3 this way, which was what, our standard deviation was 3,000, right? So 44.5, and anybody subtract 3,000 from 41.5, okay? Okay, here it is. So I know that almost 70% of the data, almost 77% of the people in this corporation earn between 38.5 and 44. Yeah. That's what I know. And then we can extend that further. Thanks for letting me go over this by 34 seconds. All right, we'll come back Thursday to finish up 2.4. Please take the time to read 2.4 by yourself. You can scan it and then take the time to look at 2.5. And then come with homework. We'll do that